Hello, everybody. We're back with another visual pattern challenge. And we've got colored boxes again. This time, I think the colors are going to help us have some intuition about what's really happening in this pattern and what's changing from step to step. So if you're not familiar with these challenges, we have a visual pattern. Here's step one, here's step two, here's step three. And your challenge, if you choose to accept it, is to predict how many boxes are going to be in the next step, in this case, step four. And then much harder, how many in step 43? And can you write an equation that would tell you how many boxes in any step you like? So if you'd like to accept that challenge, pause the video and give it a try. Okay, so as with all of these patterns, I think it pays to first just look at it and try to have some intuition about what's going on. They've helpfully color-coded this for us into two different sections of this pattern. So we've got the red. Let's look at the red first. So first we have one box, then we have four, and then we have 9. And those numbers might seem suspicious to you off the bat. If they're not, you can just look at the shape, right? It's the smallest square possible, then it's a 2 by 2 square, then it's a 3 by 3 square. So I think there's something going on here with squaring. So maybe x squared is going to be part of this equation. And then the blue part, it starts off at 1, and then it goes up to 2, and then it goes up to 3. So clearly we're adding 1 every time. So how can we sort out this pattern? Well, let's actually make a chart with the numbers. And I think this will allow us to verify some of our intuition so far. For example, I think it's going to be an x squared somehow in there. So we'll write the steps in the boxes. So in step 1, we have just 2 boxes. In step 2, we have the 4 plus 2 more, so that's 6. In step 3, we have these 9 plus 3 more, so that's 12. And what we usually do is look at the differences between the steps. So 6 minus 2 is 4. 12 minus 6, so that is 6. So these are not the same. I think it might help us to predict the next step. And I think we can do that just from our visual intuition here. This is a 1 by 1 square. This is the red part now, is a 2 by 2 square. This is a 3 by 3 square. So I think I'm going to have a 4 by 4 square in red, right? And this is 1, 2, 3 blue boxes. So I think we're going to have 4 blue boxes. So I think that's what step 4 is going to look like. If it follows this pattern. The number of boxes then in step 4 would be, well, a 4 by 4 square would have 16, plus 4 more would be 20. So here, 20 minus 12 is 8. So we have a difference of 8. Now, if these differences are all the same from step to step, you have a linear pattern. They're not here. We've got a difference of 4, then a difference of 6, then a difference of 8. When you see that, you might want to take the next set of differences. So 6 minus 4 is 2, 8 minus 6 is 2. Aha. So if in the second step, if in the difference of the differences, you get a constant, and we got 2's here, so it looks like it's staying the same, that means it's a quadratic function, and x squared is going to be in there somewhere. I don't think it's going to describe the whole thing in this case, but it's going to be in there somewhere in some form. Well, what have we done so far? We've predicted step 4, so let's go ahead and put that in there. Now, to predict step 43, there's no way I'm going to draw a square that's 43 on each side and then have 43 more things. Let's come up with an equation we can use instead. Drawing seems too difficult in this case. So for this particular pattern, I think I'm going to take it in 2 parts. So this red part, to me, that looks just like x squared, right? So this is a 1 by 1 square, that's 1 squared. This part is 2 by 2, so that's 2 squared. And this part is 3 by 3, so that's 3 squared. So the red part, I think, is just x squared. And then for the blue part, it's 1, then it's 2, then it's 3. That's really just the step number. And the step number is x, right? So we have the step number squared, and then we add the step number. And I think that's it. I think that's the whole equation. Let's test it. So this would be 1 squared plus 1. That would be 2, and that's how many boxes there are. This would be 2 squared plus 2. That'd be 4 plus 2. That's 6. That's how many boxes there are. Let's try it for step 3. That would be 3 squared plus 3. 3 squared is 9 plus 3 is 12. Aha. And let's just check step 4. So step 4 would be 4 squared plus 4. And 4 times 4 is 16 plus 4 is 20. That's exactly what we predicted when we drew it out. So I think we can be pretty confident that our equation is correct here. So y equals x squared plus x. All right, there's only one more thing to do here, and that is to use that equation to predict how many in step 43. And we're going to do y equals then 43 squared plus an additional 43. So 43 times 43 is 1,849. And then we're going to add another 43 on there, and that should be 1,892. Correct that if it's wrong. I think that's right. So 1,892 boxes in step 43. Well, how did you do? Did you get this next step, step number 4? Did you get all the way to step 43? Let me know. Thanks, everybody.